this video, we're going to talk about how to calculate the point of intersection between a straight line and a circle. Now, in previous videos, we discussed how to get the point of intersection between two straight lines. And in this case, the theory is exactly the same, right? Because you're dealing with two functions that are on a Cartesian plane. So I'm going to draw a Cartesian plane over here. And essentially what we have here is we have two functions, right? So in this case, we're going to be dealing with a circle. And we have a straight line, right? And essentially what a point of intersection is, right? Because we still have our y-axis and we have our x-axis. A point of intersection is a point where the two graphs have exactly the same x and exactly the same y. So in this case, a line and a circle, ideally, they're going to have 2 points of intersection. We have this point over here. We have that point over there. And at that point, right, the line and the circle have the exact same coordinates, which means they have the exact same x at this point. They have the exact same y at that point. And the same thing happens over there. They've got the exact same x at this point and the exact same y at that point. So if we have two different functions with the same x values and the same y values, right? So they share the same x and the same y, and you've got two separate functions. That becomes a simultaneous equation. So the moment you have intersections, remember that you're dealing with simultaneous equations. Right, so that's the first thing that you just always click when you see the word intersection. So we're going to use a couple of examples. The first one is going to be simple, right? The first example is basically going to be, you have two functions. The first function is x squared plus y squared is equal to 3. That is your circle, right? Because remember, your circle follows the equation x minus x1 squared plus y minus y1 squared, and that's equal to your r squared. So in this case, we have our x term over here, our y term over here, and then you have a constant that's not actually supposed to be 3. This is supposed to be 9. Let's write in 9 over here. Okay, so this is our circle, right? And then we have a second equation. Let's just remove these arrows. Okay, we have a second equation which says y is equal to x plus 3. And the goal of this question is we need to find the 2 points of intersection of these two graphs, right? So I'm going to try to draw the sketches after this, but essentially I want to show you the mathematical method that we're going to use with these questions. Essentially what we do is we say, okay, we have two separate functions. Like I said, because they share the exact same x's and the exact same y's, we are trying to find the point of intersections based on simultaneous equations. Now, simultaneous equations tell us that, okay, since these two equations share the same x's and y's, it means that these y's can be substituted into that equation, right? We can intermingle the x's and y's, right, in order to solve the equation. So what we're going to do is we're going to say, okay, the first, we're going to use substitution. This second equation, this y, can now be substituted into that equation over there, right? So your first equation, instead of being x squared plus y squared, now your y is going to be replaced by that expression over there, right? So that is how we substitute. So instead of having y squared, in place of y, now we have x plus 3. Now remember, your y was being squared. It's the whole of the y. The y has now been replaced by x plus 3. So it means the whole of x plus 3 needs to be squared as well, right? So just be careful about that. And that's equal to 9, right? And the reason why we do this is because now we have one single equation that we can solve for, right? One single equation with one variable. This equation only has x's. This is easier for us to solve, to find the x and the y coordinates. All right, so we're going to expand this. So this is going to be x squared plus, right? If you expand this with the squared sign, so with the expansions, you can use whatever method works for you. But I'm trying to, at these stages in these questions, if a bracket is being squared, I'm just going to go through it very quickly. But if you need to do a FOIL method or slower methods on the side, you can always do that. But as long as we come to the same answer, then you're good. All right, so hopefully that's not too much of an issue. Okay, so when we square a bracket, we say this first expression squared to give us x squared. And then we say this multiplied by this, which gives you 3x, right? But you have to multiply that by 2. That gives you positive 6x. And then you then say this second expression squared. So 3 squared is 9. All right, so that is the square of that bracket. And that's equal to 9. And then we're going to simplify our expression to give us x squared plus x squared plus, because this positive multiplies in and it doesn't really change anything. So we can remove that bracket. And then we're going to group our like terms. So we're going to have x squared plus x squared, which gives us 2x squared plus 6x plus, now we want to bring the 9 to that side because remember, in fact, let me just point something out that's very important. We have a quadratic expression because we have an x squared term, right? And if we want to solve quadratic equations, we need everything to be on the same side. So this expression then becomes plus 9 minus 9. Plus 9 minus 9 gives us a 0. So those two things are actually going to cancel. So I'm going to remove these. So our expression is now 2x squared plus 6x is equal to 0 because that 9 came to that side. It got eliminated. So all we have left is a 0. All right. Now, the one thing that I want to point out over here is an instinct for a lot of students at this stage is to be, okay, we have an x term here. We can just divide by the x's. Don't do that, right? Because the moment you divide by the variable, that by an unknown variable, we're losing data in our expression. So never divide by an unknown expression. Never divide by x or by y. Divide constant terms to get rid of them. That's fine. But so in this case, what we're going to do is how you need to solve that if you have a constant term over here is to factor it out. So now if you factor out your x, right? In fact, you can factor out a 2x in this case. Over here, we're now left with x because you removed 2x and the only thing you're left with is an x. Over here, you removed 2, which means you're left with 3. And then you remove the x, so which means you don't have any x's left. All right, that's equal to 0. What factorization does is it then allows us to then say, okay, we have 2 brackets. In order to solve this, we can say, okay, the first bracket is going to be equal to the 0. Or the second bracket can also be equal to the 0. All right? So 2x is equal to 0, which means divide both sides by 2. So your x becomes, 0 divided by 2. So your x is equal to 0. On this expression, your x is, you take this to the other side, it becomes x is equal to negative 3. So those are the two x values of our point of intersection. So now we know that our x-intercepts at x is equal to 0 and x is equal to negative 3. But if you're and you need to be careful with coordinate geometry because the language is important. If you're asked for coordinates, it means both x and y, right? So it's not enough for us just to solve the x value. We need to solve for the y value, all right? So we now need to say, okay, back to our expression. When x is equal to 0, what's the y term, right? Let's do this. Your y expression, which is this one, it was x plus 3, right? Y is equal to x plus 3, which means when x is equal to 0, your y becomes 0 plus 3. Therefore, your y is equal to positive 3. Same thing when x is equal to negative 3. Your y expression is still the same. So that's x plus 3. So then that becomes y is equal to negative 3 plus 3. And therefore, negative 3 plus 3 is the same as 3 minus 3. That's equal to 0. All right? So here are your two coordinates. Your two coordinates of the point of intersection are, the first one was when x is equal to 0, y was equal to 3. So 0 and 3. And then your second one was when x is equal to to negative 3, y was equal to 0. So this is your second coordinate over here. So those are your 2 points of intersection, right? And in order for it to hopefully to make a little bit more sense, I'm going to try to draw these 2 expressions, right? These 2 graphs. So what we're going to do is we're going to take this, all right? So maybe this is going to be for our more visual learners, right? And then also it's a little bit of practice of, because we've talked about how to calculate, we know how to, hopefully we know how to distinguish equations of circles, equations of lines, and so on. So hopefully we can use our knowledge to draw and sketch the graphs and see if our answers make sense. All right. So we're going to draw a Cartesian plane. Okay. Let's just change color there. So we have our y-axis, we have our x-axis. Okay. So we start off with the circle, right? For the circle, we said this is, so your equation of a circle is x minus your x coordinate of your center. Let's just write that down. The equation of a circle usually goes x minus x1 all squared plus y minus y1 all squared is equal to r squared, right? So in this case, your x squared, because there's no other x term, right? We know that this is the only x expression, which means this is basically the same as saying x minus 0 squared. All right. So that means your x coordinate is going to be 0. And then for the y, it's the same thing because there's no other y expression that's there, which means there hasn't been any expansion that's happened. So in this case, we can also interpret this as y minus 0 squared. And then over here, we have a the 9 is basically 3 squared. So we can tell that our radius is going to be 3. So let's try to draw that, right? So we're going to have our circle. So that means your x coordinate of your center is 0. Your y coordinate of your center is 0. That means it's at the origin, right? And then your radius is going to be 3. So it means maybe, let's say our 3 is over there. Our circle looks, let's just do it like this, right? Where it goes from 0 because the radius is 3. That means it's going to go to positive 3 on this side, positive 3 on this side. And then in the negative y direction, it goes to negative 3 and negative 3. All right, so this, remember, this is your x and this is your y. Okay. And then with the straight line as well, right? So how do we deal with straight lines? Straight lines, we know that for straight lines, we can just tell directly, since it's in the form y is equal to mx plus c, we can actually already tell that the c value is positive 3. So it actually is supposed to intersect right there. But in order for us to be able to draw a straight line, we need a second point, and we can connect those 2 points, right? So let's just let's say, so we know where it is on the y-axis. Maybe let's see where it's at on the x-axis. So we're going to take the equation, y is equal to x plus 3, and say, okay, on the x-axis, your y is equal to 0. So we're going to say y is 0 plus 3. Therefore, your x value is equal to negative 3. So this is the second point. So on the x-axis, your x is equal to negative 3. So your point, your circle, actually is going to cross right there. Like that, right? And essentially, you can tell that these are 2 answers at 0 and positive 3, which means your x value is 0 and your y value is positive 3. So we can tell that yes, that answer makes sense. Your second answer was at negative 3 and 0, right? Which is on the y-axis, your x is equal to negative 3, right? So essentially, this is what it looks like graphically, right? But when it comes to your questions in your exam, whenever, all you need to know is the mathematics of it, or at least, it's good to be able to interpret, right? But the majority of it is understanding the mathematics of it. Where if I give you the equation of a circle and I give you the equation of a line, the moment we're trying to get to the point of intersection, I'm asking you to calculate, to solve, or to use simultaneous equations to solve the points where they intersect, which means it's the point where they share the same x and y, right? So that is the foundational thing that you need to understand at this point. And then maybe we might need to trick it up a little bit for our exams. But for now, I was supposed to do 2 examples in this case, but I think as a starter, we'll just leave it off at this example. And then in the next video, we'll just do another example, one that's a little bit trickier. And then hopefully that will make sense. And then we'll start to talk about tangents and 2 points of intersections and no point of intersections and all of that stuff. But for now, hopefully this makes sense, and I'll see you in the next video.